We've been told that we have an angle in quadrant 3. So first of all, make sure that we draw whatever we're drawing is going to end up in this quadrant. Okay, because the quadrant location is very important. And we're told that the position of that angle is given by -4, +5. So we're going to draw something like this. Okay, so my radius is 5. I've gone to the left 4. And I'm being asked to find sine theta, tan theta. Well, if that's the case, then what I should do is I should find that third side using Pythagoras. I get 25 minus 16 is 9. Square root of 9 is 3. Now again, because of the positioning is down. It's really important to put that negative in there. So I'm going to actually I'm going to highlight that negative because we have to make sure we have the right quadrant. Okay, we need the location in the right position. So once we've established that, we can then just write our sine ratio. Sine ratio is equal to the vertical over the radius. The tan ratio is slope, so I know it's sloping up. So the tan ratio is -3 rise over -4 run. It just works out to be +3 over 4. We have a positive slope. Now, it doesn't ask us for the angle, but if we were to undo the cosine here, so I'm just going to put a little star here because this wasn't part of the question, but if I undo the cos with a cosine, arc cosine, our inverse cosine only actually gives us angles in quadrants 1 and 2. So when we do this, we end up with 2.498, so I'm going to round that to 50. Okay, well, 2.50 is in the wrong spot. 2.50 is in quadrant 2 because this is 1.57 approximately. This is 3.14 as a reference. So we're definitely in the wrong quadrant. Okay, I'm just going to draw it here. We're actually over here, right? We've got the symmetrical point. So this being theta 1, the theta 2, we have to find using the symmetry. So this is theta 1. What we really want is this angle in here, which we're going to call theta 2. And theta 2, the correct position, is going to be at 3 when we subtract 2 pi minus that, we get 3.785. So we're going to round that to 79. Okay. This next question gives us this, we're talking about the same angle. Okay, so this angle in quadrant 3, it happens to be 3.79, but we don't actually need the measurement. We want to draw a new angle alpha, and that angle alpha is theta plus 90 degrees, or pi over 2. So I'm just going to draw in where that might be. So it's going to look something like this. And in fact, if I kind of trace out the triangle here, that's like rotating the triangle 90 degrees. So this angle here is 90 degrees, and it locates this new position. Okay, so this is angle alpha. Okay, when I locate that position from here to here, that's my angle alpha. And I'm going to draw my reference triangle here. We should really look at it from the x-axis, the triangle from the x-axis. And we can see that we have some measurements. If we use equivalent ratios that we had before, we have 5 here. We know that that length is 4 and that length is 3. Now, because of the positioning of those, we need to observe whether it's positive or negative. The horizontal is definitely +3. The vertical, however, is down 4. So again, I'm going to highlight that because that down 4 is important. Just going to highlight that there. Okay. So the new x and y position that locates that angle, then we can locate that angle with this coordinate of +3, -4, and that will locate the angle alpha in terms of an x and y position.